Hello everyone, my name is Wan Lin. My project here is a risk assessment of the $1 million question, should I drive? So let's start with a much simpler question. When you're navigating around a big city like San Francisco, which way do you prefer the most? So for the big cities like San Francisco, the good thing about it is you could have multiple choices. You could bike, you could take a Muni, or you could take Uber or Lyft. You could also drive. So if you're like me, I would still prefer driving. Then I bump into another question: where could I park? Among all the parking solutions, I would still prefer metered parking because the regulation is most straightforward, and it's cheaper than most parking garages. Then another question arises: how can I know that if I can find a metered parking before I start to choose my transportation methods? To help the situation a little bit, I'm proposing a solution where you gave me the estimated arriving time, the destination of your like, and the walking range you prefer. I took all these requests and dig into the San Francisco parking event transaction data, find out how many parking meters are actually occupied based on your condition. Let's say in this particular case, I only have 20% of them occupied. Let's try my luck. So the architecture is kind of simple. So we get all the data from San Francisco Open Database. Then I save them in Amazon S3. Then the data flow into Spark Cluster to get cleaned, pre-processed, then saved into PostgreSQL, and then the result will be delivered to customers through Dash. So challenges. So the data provided from San Francisco is transactional events. So it has a start time and an end time for each parking event. So for me, really to know if the parking meter is occupied or not, I have to use a user input time to compare against and start and end time. So my data size is not terribly large, but my records are. I have about 840 million records for me to compare one by one. Because the time and location are really dependent on user input, I cannot pre-process them without losing time resolution. So PostGIS did a pretty good job that it filters data sets into 1.5%, but that still left me about 12.6 million records. So I know I can't do that. I can't just compare the time directly. So I create start window and end window. I round up a time into 15-minute buckets. These are served as indexes. So whenever I need to query, I grab the data in the red buckets. But at this time, I'm still not ready to lose my time resolution. So actually want to do the comparison, I still use the start and end time to do the comparison. This didn't work very well. I couldn't even get the result after I had lunch. So I've been thinking this is historical data. I don't have to be that accurate. So I use the start and end window, which I round up to 15 minutes windows to compare the time. It gets better. I got something after 15 minutes. I know nobody could wait for that. So I've been thinking I could further partition the data. So I partitioned them into 7 different smaller tables based on the day, and then I further truncate the time into hours. So this relatively okay. I got something back after 1.5 minutes, but I know this is still not good enough. And also I've been thinking at this moment, the reason I didn't want to pre-process the data in the beginning is because I don't want to lose the time resolution. However, I'm losing it now. So why don't I just pre-process them? So then I pre-process the data and save them in the PostgreSQL. When I query the data, it gives me 0.6 in responding time. So let's see what it really looks like. So let's start with any time. Let's say 100. These are the places I have been before. So for this this is the average occupancy rate. And if you hover to each meter, it gives you what's the possibility of each meter that would be occupied based on your condition. So coming back to the presentation, a little bit about me. My name is Wan Lin. I graduated from Rutgers University with a mechanical engineering PhD. After graduation, I worked as a process engineer, and I really understand the pain that you don't have the data or the data is not convenient. So that shaped my interest from a data end user to the data facilitator, I would say. So thank you so much.